Uh, Hello friends, we have already started the topic related to data science process. Four, five steps are there already. I have given some introduction about the retrieving data, data preparation, data exploration. So after the data visualization, then we have to go for the data modeling. Okay. So after data visualization, you can get the idea what are the parameters you need to delete, what are the parameters you need to modify, any kind of the data manipulation, everything we can do before the data modeling. So clean data and the minimum data and clean data, most important data should be only entered into the data model. Okay, what is the data modeling? Suppose you have data in X, suppose X and Y are available. So you need to, for a particular X, you need to predict the Y. For that, you need the data modeling. Okay, data modeling that only mainly come into the machine learning concept, but it is also related to data science. So data science is the before the data modeling, what are the steps are that this is the main important for data science. After that, the machine learning which can only deal with the modeling. Okay, this is the data modeling. So data science is related to the analysis of the data as well as the data modeling for predicting something. Okay, so the data modeling, there are the three parts. One is the model and the variable selection, model execution, model comparison. Okay, the three steps, how you can select the model, and if you select the model, so what are the parameters need to feed into the model? After that, the execution of the model, and then last, suppose you are using the five model for the evaluation. Okay, so which model is going to give the good performance? That is, you have to check. With respect to model comparison. After then, we can tell that the okay, this the particular model which can be used for predicting the this application, predicting something for this application, right? So, and now first come to the model and the variable selection. Model selection means suppose mm, after observing the data, after visualizing the data only, you can identify that what are the models are used for this your particular application. Suppose you need to deal with the some categorical, so your output y is related to categorical, either yes or no. Okay, suppose your output is now related to numerical value 0, 1, 2, 3 like this. Based on the your output types of the output, the requirement of the applications, you need to select the what algorithm. Okay, so after selecting algorithm, then you have to check the algorithm model performance. Okay, under the model performance, the accuracy, precision, recall, RMSC, overfitting, underfitting, this also you need to consider based on the so some already if you if you go through the some literature, already you will get to know okay which model will be, suppose you have the numerous models, already you get to know through the literature survey which model will be used for less overfitting, less underfitting, which models can be give good accuracy, or already you can get to know these things, right? So based on that, you can select the model. After selecting the model, you have to go for the variable selection. Whether all the suppose you have the 20 attributes, whether all the 20 attributes are required for predicting the output. Sometimes some if all the 20 parameters you feed into the model, sometimes you will get the overfitting. Suppose from the 20 parameters, suppose if you are giving only overfitting or underfitting, suppose you give only the two parameters for model, again also you will get some problem related to overfitting and underfitting. So you have to select that which parameters are important. This is called the feature selection. There are the various processes or models are used for the selecting the features which can be relevant with the predictor, right? So this is about the variable selection. After selecting the variable and the model, suppose you are going to use the five models and you have selected already from the out of 20 features, you have already selected the 15 features. Now these 15 features you feed into the model. So if how can you write the model? Suppose some algorithms or package you need to import.
Okay, NumPy also here in this program. NumPy is also very important. After that, suppose you have to write down the input parameters, then you have to feed the input parameters to the model. Okay. After that, once you get the model, proper model, then the model you have to, with the help of the model, you have to predict the output value. Okay, so you have to write the set of instruction. You have to write down the set of instruction of the code. Okay, you will not get confused with this one. Okay, so these are mainly related to machine learning. So I am not going to discuss depth by depth of each and every line. Normally, you need the input. Okay, after that you feed the input into the model. Okay, so five models are there. You will get some output. This output you compare with your original output. Based on the accuracy, based on the error, you will get to know which model is the good model, right? So after that, if the out of five model, if you identify that one model is good, then this model you again through this model you will feed the new test input parameter for predicting the output. Okay. So later I'll discuss about this thing. I'm not going to depth in this part. So this is the some graph are there from the graph you can suppose this is your target variable. Suppose this output you should get, but you are getting the this. So this is the x, this is the x, and this is the y. The blue color, blue color dots are the your actual output, and red line is the your predicted output. Okay. So if this blue color line is overlapping with the predicted output, that means the model is suitable for predicting any parameter for related to any unknown x. Okay, so there are some parameters through which you can do this thing. Okay, and so after get so suppose you executed five models, which model will be suitable? So after executing model, you can get some parameters that the model evaluation metric parameter or performance metrics we used to tell. One is the R square. So R square should be very much high for better model performance. Okay. Suppose here it is 0.893, so you should get almost near to 1. So this is the one R square which is most important for finding the whether this model is suitable or not for this application, right? And apart from that, you have the RMSC also. RMSC value you can also get from here only. And so based on the classification and the regression is you have the numerical inputs and output. So classification means you have the categorical output based on the regression, or classification. You have to choose the model, and based on the model, the performance metrics will be varied. Okay, so you have to check the performance metric.
So now come to the NumPy. So this is one of the NumPy the required for dealing with the data science. Normally is the numerical Python, and so that means if you want to write any code, if you want to write any code, if a list, if you want to design a array, after that you want to do the any operation with the array, for that the new NumPy is required. The full form is the numerical Python. It has the lots of processing package and library. With the help of this thing, you can do some scientific computation with the help of the NumPy. Okay, so if you want to write a Python language for some scientific computation, so Python, the new NumPy is the one of the suitable package. Under NumPy, if we have the lots of scientific calculation, scientific formulas are there or functions are there, we can call those function. You can do some scientific calculation and the computation. Right, so it is also open source platform. So just if you open the Google Colab, if you call the NumPy library, you can write down the code with respect to array and the some NumPy, right? So you can create a n-dimensional NumPy array, and it is also so it can integrate with the C and C++, and various type of the linear algebra, Fourier transform, the random number generation can be possible with the help of the NumPy, right? So NumPy is more computation. The computational speed is more.
of the NumPy as compared to the other Python library, right? So normally for array generation, we used to prefer the NumPy, and for scientific calculation, we used to prefer the NumPy. So what is the array? You can store a multiple values in a one identifier, in a one variable name. You can store a multiple values, and which will be in order values. Okay, it should be in order. And the for identifying the particular value in this array, you have the index. So I will give you the example now. And suppose suppose x is equal to, or a is equal to this 10, 9, and 9, 71, 90. So the a is one variable where you can store the multiple variables. To identify in the value from the a, you can give the position name as the index. So suppose the this is 0, this is 1, this is 2, this is 3, and this is 4. Okay, so you can, so suppose a within bracket, if you write 0, so that means you are identifying the 10 element presence in the a. Okay. So NumPy array, this is like a array only for you can store the multiple values in a one variable. After that, you can do some various kind of the manipulation in the array. That was creating the array, manipulation the array, transforming the array. For that, the NumPy array is you can easy use the NumPy array. Normal array and the NumPy array, normal can do the various operation with the NumPy array. So the list, and now we can tell that if you know the Python, list is also similar to the array, but the list you can store the various data type values, but in case of the array you can only store the numerical data. And for the list, for calling the list, you need to call any particular function. For generating the array, NumPy function is required, and you cannot do any arithmetic operation in the list. But in case of the array, with the help of the NumPy array, you can do various kind of the arithmetic operation. So if you want to call the NumPy array, you have to write like this: import NumPy as NP. And you can using the NumPy, you can do you can create the array, or using the some other function also you can create the array. In upcoming lecture, I will show you the how can you create the array with the help of the NumPy. How what are the operation can be done using the NumPy. This I will discuss in the next class. So before ending the lecture, so I will show you something. So suppose the multi-dimension array we can create with the NumPy. So suppose the array addition we can do with the NumPy. So any slicing, if you want to retrieve some data from the array, this also can be used with the help of the NumPy. There's indexing, broadcasting, multiplication, reduction. If you want to reduce the multiple array to one single dimensional array, this also can be possible. Copy of the array from one location to another location, various condition, this can be also done with the help of the NumPy. So there are the various operations. Now you can see the searching, sorting, counting, mathematical operation, linear algebra, matrix operation, copying and viewing arrays, stacking, bitwise operation, arithmetic operation, statistical operation. Various operations are possible using the NumPy. If we generate the array, various operations will be possible with the help of the NumPy. So I am ending my lecture. Next class I will give you some I will show you some demonstration with the help of the NumPy. Please like, share and subscribe my channel. Thank you.